Hi, my name is Kelly Dark, the Fairy Math Mother. I am a mathematical mentor for parents, and I am here to try to answer your questions. This video is my answer to a question from a first grade parent about addition fact strategies. Here's a question from a first grade parent. How important is it for a child to understand strategies like making 10 and doubles plus 1, especially if they already know the answer to an addition problem like 7 plus 5? If you're unfamiliar with the strategies making 10 and doubles plus 1, I've posted two different videos on YouTube on my channel. One is about near doubles and one is about making 10. To answer this question, I want to start first by looking at the three different phases children typically go through as they learn basic facts. The first phase is they will solve problems with addition using counting strategies. They might model with some blocks, they'll use their fingers, and eventually they'll start internalizing their counting strategies in their head. The second phase is they'll use derived strategies, and making 10 and doubles plus 1 are examples of derived strategies. In this phase, students have some known facts that they're really comfortable with, and they'll use those known facts to derive other facts. The third phase is mastery, and that's where a child is given a basic fact and they can efficiently give you the answer. In the same article where Baruti outlined these phases, he gave a task, and I want to give that task to you now. So it's just to memorize this number. So I'll give you 15 seconds to memorize this number. Okay, I hope that was 15 seconds. I'm going to have you recite to your computer in a second that number or write it down, and we'll check how well your memorization worked right now. So you can check whether you memorized it right. If I went too quickly and you didn't get your piece of paper, you can go back and try it again. But the point I want to make is that if you memorize the number right now and we're efficient and you have the same number, what about in 2 days or in a week? Or if I asked you to tell me that number in a month or a year, how confident are you that you could recite that same number? For most of us, if we used rote memorization to memorize it, we'd probably forget it. So the point Baruti was making was that if we look for patterns in numbers, so I'm going to just start drawing on this number and you might notice a pattern. So I'm going to chunk, sorry, that little curve didn't work very well, but hopefully when I chunk this number, you might notice a pattern. And the argument would be that if you look at 2 and 5 and compare them, as you move up from 2 to 5, you can think of it as adding 3, and then adding 3 again, and then adding 3. 8 plus 3 is 11. 11 plus 3 is 14, okay, and so on. So by looking for a pattern or relationship, we would probably be more confident that we could remember this number. We have a number that starts at 2, it ends in 0, and it goes up by 3 each time. So 2 plus 3 is 5, and we could remember it probably easier than if we just worked on rote memorization. And that's the point with derived strategies. There's some kind of meaningful structure behind the strategy to support students other than rote memorization. So here's an addition table, and what I've highlighted here are the plus 0, plus 1, and plus 2 facts. These are typically easy facts when students have worked a lot with their counting strategies, they've modeled, they've thought a lot about addition situations. These are facts that become foundational facts for children. 10 plus facts are also foundational facts. So our number system is based on 10. So when we add 10 plus 3, we get the number 13. And 13 has 1 10 and 3 ones. So if you decompose 13 into 10 plus 3, the relationship between the place value and the 10 facts, there's a connection there. So the 10 plus facts are foundational facts for children. And as they work with different counting strategies, different representations like tens frames, their 10 plus facts get stronger and more fluent. Doubles facts is another foundational fact. So a fact like 3 plus 3 or 4 plus 4. And then combinations of 10. Our number system is based on units of 10. So being able to break up 10 in different ways is a key foundational skill. So right now in this table, I've highlighted all these foundational facts. The idea is that there's some white space. Now we can go about and tell students they have to memorize these through rote memorization, or we can go through and discuss some ways of using derived strategies. So for a student that's unsure about 8 plus 9, this is the fact I've highlighted here, 8 plus 9, they're unsure. They might use a counting strategy in their head and they're getting kind of nervous because these numbers are pretty big. They could use a derived strategy to think about and get access to this fact of 8 plus 9. So students that know facts from memory after they've gone through these steps of direct modeling, counting strategies, and then derived facts, they have a stronger understanding of addition and subtraction than students that learn through rote memorization only. Now, there are some pitfalls to derived strategies, and I'm going to use a worked example that the parent that posed this question sent me to try to highlight some of these pitfalls. And this can lead to some frustration on the parent's part for sure. How do I help my child? And there might be some pitfalls underlying what's the issues is. So the first pitfall is there might be some insufficient mastery with their foundational facts. So maybe your child doesn't have the foundation they need to use a particular derived fact. The second one is there wasn't enough practice, and the third one was the strategy was shown but not really learned. So this is a worksheet similar to the worksheet image that the parent that asked the question sent me. I just changed the numbers. So here is a worked example the child is supposed to make sense of. It has a lot of representation here. So you have this piece of representation where 5 is subdivided and the 8 and the 2 are circled. You have this representation, pictorial representation of each addend, and then you have 3 equations, which is a lot for a first grader to parse. In addition, it's a static representation of a process that is dynamic. It's a sense-making process to make 10. So the first thing that I would suggest is to remember that first pitfall. In order to use make 10 strategy, your child needs those foundational facts. So there's 2 sets of foundational facts I'd want to check first. And you can see them in this set of equations. So the first set of foundational facts, those highlighted facts that I went through the PowerPoint on, is 8 plus 2 equals 10. That's a combo fact. So you want to make sure your child has fluency with combos to 10. Otherwise, this strategy is not useful at all, this make 10 strategy. The second set is the 10 plus facts. So in this case, we're finding 10 plus 3 equals 13. So those are the 2 sets, the combos of 10 and the 10 plus facts, that are necessary in order for them to use this derived fact of make 10. So if your child is really strong on those, they still might not understand this representation. Like I said, it's a lot for a first grader to parse. So my suggestion would be to set the worksheet aside and just explore and practice with your child. Break up numbers, try to think about ways that you can use one of the numbers to make a 10. Again, I have a video on YouTube about the making a 10 strategy. So exploring more and more problems, breaking up numbers. That's the whole point of making 10, the making 10 strategy and all these derived strategies, is it has to be grounded in sense. Otherwise, trying to fill out something like this can end up being a rote process. So the third pitfall is that the strategy is the strategy is shown, but it's not learned. And if a child learns making 10 rotely, then there's a good chance they're not going to remember it. So to avoid that, practicing with your child, asking them questions about how they broke up numbers, why they broke them up that way, and having them show you their strategy would be helpful. And then the last thing I'd say about this worksheet to this particular parent is ask your teacher for some advice. You can get more information as you practice with your child, and you'll know whether they have the foundational facts. But ask your teacher about how to support your child completing a worksheet like this. And they'll have more information about what their expectations are. All right, so why spend time on these derived strategies? They support mastery of basic addition facts. They help develop number sense. You're composing and decomposing numbers, especially units of 10. You're applying different properties of addition. Students have to group numbers in different ways when they're using these derived strategies, and they're doing this in an intuitive way. And these are properties of addition, the associative property, they're using the commutative property. They also explore different patterns and relationships, which is a key habit of mine in mathematics. And while they're working the derived strategies, they're building fluency and confidence with numbers. They're able to break up numbers. They're understanding the operation of addition. Derived strategies also support later learning. So for an example, when students are learning multi-digit addition, being able to break up numbers and think about how to combine numbers, the work they've done with derived strategies will support multi-digit addition, but also mental math. So if you were going to solve the problem 999 plus 31, a student with a strong number sense might think about breaking that 31 up into 30 and 1 and realize that the answer to this problem is 1,030 because they're just going to make 1,000 with the 1 from the 31 and the 999. So it's not make a 10, but it's generalizing that to make 1,000. Thanks to that parent for sending in that question. I know that was a really long answer, but it was a really big question. I hope you found that helpful, and if you did, you can subscribe to my YouTube channel to get updates when I post new videos. Just click on the subscribe button in the right-hand bottom corner. And also, if you have your own question when you're helping your child, you can submit your question to me 4 different ways, and the next slide I'll leave that at the end of the video so you can copy that information down. Thank you for visiting, and please send your questions soon. I am excited to hear from you. Thank you.